welcome to the MOOCs course, Internet of Things, Design Concepts and Use Cases. In today's session, we are going to talk about Arduino-based hardware design for agriculture application. As you already know that we are going to cover a detailed hardware structure for a specific application in today's session. In the previous video, you might have learned about the basics of agriculture monitoring with IoT, and you might have also gone through different applications that are possible with IoT on agriculture sector, along with various types of hardwares or the sensors especially that are being used for these kind of applications. Now, in this study, we are going to consider a monitoring case for greenhouse. For instance, if you have some plants inserted in a greenhouse area and you need a continuous monitoring in that area, so how you can do that with the help of sensor network designed using IoT. In order to do this, we are going to utilize variety of sensors. I can display a circuit diagram in front of you. You can see that we are going to use multiple sensors in this project along with your Arduino Uno board, LCD board, breadboard and buzzer and LEDs. There are 6 different sensors that you can see on the screen right now. All these 6 sensors we have interfaced individually in previous videos. So I am very much sure that you might have practiced with those sensors and now you are clear with the basic idea of this design. So when we create a project-based application, then we have to combine all these individual sensors into a single circuit that you can see on the screen right now. You will find a VCC supply on the breadboard, and at the same time we have ground supply on the other side of the breadboard. While making connections, I have used here the green wires for all the ground and red wires for all the VCC connections. Remaining your data lines as well as the pin connections with the buzzer, LED and LCD modules, I have used black wires. So you can identify it easily from the circuit diagram itself. Following this connection, because whenever we have to design a hardware based Arduino system, in that case you need a code as well. And as you already know, we design that code using Arduino IDE environment. So the same process we are going to follow now. You can see here on the hardware side that for every sensor we have 3 different pins, out of which one you are going to connect with the VCC supply, one you have to connect with the ground, and the third pin will be your data or signal line that you have to connect on the Arduino. Some of these sensors we are going to use on the analog port and few others will be used on the digital port. At the same time, the LCD board, as you already know, it has 4 different wires and we can connect it with VCC, ground, and other than this, the serial interface that you already know, we have SDA and SCL line by the end of your digital port. So the similar kind of connections we are going to follow on the hardware side as well. But before we do that, let us have a close discussion with the coding section of this hardware design so that you can understand different aspects of design for the coding aspects as well. And as you know, we will be using IDE platform for this purpose. While working on the IDE platform, you know that we have to first work on your ideas for library management, your sensor management, as well as the pin descriptions, your setup part and your loop part. So let us discuss each one of these sections one by one. We are going to start with the library section first of all. For this entire code, because we are going to interface now multiple sensors, so definitely this is going to be a bigger code. But in order to make it easy to understand for the beginners like you, I have segregated it precisely into different sections and accordingly we are going to understand it step by step. So the first most section is about libraries. You can see here we have included 2 important libraries. One is for your liquid crystal I2C and second one is for your DHT11 sensor. We have only one sensor in this project that works with the library. Remaining all sensors can work without any library because they are very basic sensors and doesn't require support from a library. At the same time, as you know, while we work on the DHT sensor, we use an object with this. So, DHT object we have declared here with your DHT11 sensor, and we can call it with the DHT name throughout the program. After this, we have your liquid crystal I2C declaration. We have already studied how we create this address. You can use the wire library for the scanning purpose, and once you get address of your I2C board, accordingly you can mention it here. After this, we have displayed the size of your LCD board. Depending upon whether you are using 16 x 2, 16 x 4 or 20 x 4, any of these LCD boards, you can mention its size within these brackets. After declaring your initial variables, now we have to define pins for all your sensors here. So, I am starting with your DHT11 sensor. You can see here we have pin number 7 declared for DHT11 data line, and because this sensor provides you two parameters that we have already studied as well. So, from those two parameters we are going to declare the variables here. First is int humidity and second is int temperature. It completely depends upon you whether you want to use it as a float variable or as an int variable. So, accordingly we can make the declaration here. After this, we have the second sensor here. Because I am monitoring CO2 in this greenhouse project, so for monitoring CO2 I will be using MQ135 sensor. For monitoring different gases, you can pick up other sensors from the MQ series. Some of these we have already discussed in the previous videos. So, here you can see, because this MQ135 sensor work on analog ports, so accordingly I have declared it on A2 pin here. And then we have the variable declaration for CO2. This shows int CO2. You can also have the float variables for this. After this, we have the motion detector sensor, and for motion detector here I have declared it on pin number 3 of your Arduino digital port, and we have the variable declaration as well. Now, there is one important mention again, because your IR motion sensor provides you signal in the form of 0 and 1. So, based on that 0 and 1, we are going to declare the initial state of the sensor first. So, most of the time when you have sensors that communicate with 0 and 1, we declare their initial state. So, here also you can see that the obstacle information I have declared with int has obstacle variable. You can take any name for this variable, but the initial value I have given it is high. It means it will display high when there is no obstacle. And then one LED pin I have declared in association with this motion sensor. This LED pin will turn on automatically when your motion sensor detects some object in front of it. After this, we have the soil moisture sensor. As you can see, it works on analog pin. So, therefore, I have declared it over A0 here. And the variable for this I have also declared as int soil sensor value. Next to this, you will find water level sensor. This sensor again works on the analog port. So, you can see I have declared it on A0 line, and along with this the variable water well I have initialized here as an int variable. Along with your water level sensor, I have declared a buzzer here, because I want to create a actuation in the form of a buzzer out there, so that whenever your water level in that specific area reaches a certain threshold level, a buzzer can ring automatically. So for a greenhouse project, you can even consider it like an hypothesis where maybe you have some irrigation system or automatic pumping mechanism, and if it reaches a certain threshold, maybe the tank or maybe the surrounding areas, whatever you are covering with your pumping mechanism, so if certain water threshold is achieved, a buzzer can ring and the farmers or the caretakers can take relevant actions based on this. After this, we have the last sensor, which is your LDR sensor, and you can see I have connected it on pin number 10, and I have declared a variable initially 0 for this LDR section, and along with this I have a lamp associated with the LDR. So as you have already seen the operation of LDR, it will help you to glow this lamp 9 whenever the LDR sensor senses darkness around. So that maybe in your greenhouse, if you need some illumination in the night hours, this LDR will help you to turn on lights automatically without requiring any manual intervention. So this is your declaration part. Now we come to the setup section. Within your setup section, as you know, we first have to initialize few things. The first part we have with your LCD. So I am just initializing it, I am clearing any existing information, and I am also turning on the backlit. At the same time, the serial monitor is to be initialized, and that I am doing with 9600 baud rate. After this, I have declarations for all your sensors, and you can see we have to declare them as an input, as an output. So depending upon how you are going to use your all the peripherals, accordingly the pin mode declarations we have to make. For instance, all your sensors will work as an input device. Your LEDs, motors, or we can have buzzers, etc. If you have any such things, they can become your output devices. So accordingly, in this code also you will find all sensors declared as an input device. The LEDs and buzzer is declared as an output section. So this completes your setup part. Now we have the most important one, which is the loop section of the code. And in the loop section, as you already know, we keep up everything about the field environment and the variables that we are going to read from the field environment, as well as the display controls we manage within the loop section. So it starts again with your DHT sensor. First of all, we are trying to read the variables from the field with the help of this read command, which is associated with your DHT robot library. For this, first I am reading from the DHT pin, and then I am saving both variables, temperature and humidity, in your pre-declared variables, which is temp and hum variable we have declared as an int variable in the beginning of your code. In the similar pattern now, we will be following it for the remaining sensors as well. So first we can see here the CO2 sensor. Since it is connected on the analog port, so automatically we are going to use here analog read with CO2 sensor. Similarly, we have this for the soil sensor, and on the soil sensor again you can see we have analog read because I have connected it on the analog input port again. After this, we have your water level sensor, and this one of course have your analog read because this one is also connected on your analog port. Next we have your LDR sensor, and as we discussed in the circuit diagram also, this one we have connected on the digital port. So we need to use digital read in this case. With the digital read, we are getting data from the LDR pin, and it will help us understand what brightness conditions we have in the field environment. And the last sensor in the list we have is your motion sensor, from which we are getting idea about if there are some intruders in the greenhouse area, or maybe you can consider it something like if someone enters in dark hours within your this greenhouse area, At that time we can have automatic lights being turning on over there. So all those controls you can manage with the help of your sensors. In this one, I am creating a illusion like when someone enters in the greenhouse, the lights will turn on automatically, so that they by mistake do not jump on any of the plants over there. So that is just like an additional light control system we are using with the motion sensor. After this, we have the response section, because we are having sensors along with actuators in this project. So of course you need to decide response for the actuation with respect to sensor readings. In order to do that, I have created different if-else statements here. Small loops for every part I have created. For instance, first here you will find the motion sensor. When the motion sensor finds a low data from the field environment, the LED pin will turn on high automatically. I have added a very small delay of 100 over here. So accordingly 100 milliseconds you will find here. Then in the else part, we are keeping the opposite condition. It means when your motion sensor senses something in the field environment, the LED will turn on. If it does not find anything around, or if there is no motion activity detected, the LED will be staying off. In the similar manner, I have created the illumination for your LDR lamp. Whenever your LDR sensor senses darkness around, the lamp should turn on, otherwise it will stay off. So another response we have with the water sensor. So I have given a condition like when water threshold level is greater than 400, then a buzzer should ring, otherwise the buzzer will stay off. So in the similar manner, you can add more actuators like relays or motors. You can add all of them, interface them with your relevant sensors, and then you can see the activity in the output. Now we have the display part. After you have read all the values from the field environment and you are ready with the data, you definitely need to display it somewhere. So we are using two sections for the display. First one we have is with your serial monitor, and second we have is your LCD board. So first section I am going to explain with the serial monitor, and this is definitely very simple. We have used it several times in the previous videos as well. You have simple serial print commands for this. You just have to write serial print, and then within inverted commas you can add your static text, and the variables you can add without inverted commas. So this pattern we have already studied, and you can see here for all the sensors I have followed the same pattern one by one, and the values will be displayed on your serial monitor in sequence. In order to create a segregation between the repeated values, I have added up a star sequence over here, so that whenever a new value comes before that, we can have this star mark just for a segregation purpose. Otherwise you can have it based on your choice. You can add some other symbols also, that is definitely your choice, because this is just a static sequence I have added over here. Then the last section in your code is your LCD section, where we will be displaying readings on the LCD board. And as you know, for this, first of all we need to set the cursor, because we have already understood that your LCD has 2 rows and 16 columns, and we can place the cursor anywhere on these available columns or rows to display our data. Now in this project we are having multiple sensors. It means you have multiple sensor readings to display on the LCD board. So in order to accommodate that, what we can do is we can segregate different rows and columns of your LCD board for different types of sensor values. We can clear them up time to time, and we can display another set of values in sequence. So you can update a relevant set of delays after every display. You can clear the previous values, you can add new values and then clear previous, and this loop will go on. So following the same pattern, you can see here, first set I have created for temperature, humidity and CO2 values, and they are being displayed on the different sections of your LCD board by using set cursor command, and then I am just clearing up my LCD board. In the next section, I have used your moisture sensor and water level sensor on 2 rows of your LCD board, and ultimately I have cleared the values after a 2-second delay. And last one, we have your LDR sensor and motion sensor, and again I have cleared up the values. So this completes your coding section, and we have just understood how you get data with the help of all these details from the field environment. And following the same, now we are going to design the hardware. In order to design the hardware, we have two options now. Either you can follow up with the circuit diagram that I have already displayed. You can consider this circuit diagram or it's all the pin values to create your hardware. Or the second option you have is, you have the coding sequence with you and you know all the pin sequences from here. The same pin sequences you can follow while creating your hardware structure. So let us follow it from the code itself. You can design it from the circuit diagram as well. So one by one, I am going to pick all the sensors and I will be creating the hardware system with your Arduino board over here. Because now we come to the most important part. On your this Arduino board, as we already know that this power port contains limited VCC and ground connections, because we have multiple sensors to connect right now. In order to do this, we definitely need an extension over the breadboard. So I will be extending first of all two wires. One will be towards VCC and second will be towards your ground. So these two wires will be first essential, so that I can have common VCC and common ground for all my sensors. So let us start with this. First I am taking up this black wire, inserting it in the ground here and making a common connection on the ground terminal here. At the same time, I am taking up this red wire. I am using the 5 volt VCC from the Arduino board and making a common connection in this section of the breadboard. As we know, the 5 ports on these both sections are internally connected. These 5 and these 5 are horizontally connected. So once I have inserted my VCC over here, this will be connected in sequence. Similarly, the ground here will be connected in sequence up to 5 slots. Now we can follow the remaining connections. So as you can see in the coding sequence, the first one we have is with the DHT11 sensor. So let us take our DHT11 sensor. As you already know, it contains 3 pins. We have ground, we have VCC, and there is one data line. So the same we are going to follow over here. As I have discussed in the previous videos, that whenever you connect a component in your circuit, we start with the ground first, then we follow the VCC, and then we can use the data line. So following the same, what I will be doing here, this gray wire we have for your ground connection, I am inserting it in sequence right here. Then we have the last wire for your VCC, we can insert it here. The middle one on my sensor is data, and if you look at your code, we have this line on the pin number 7 of digital port. So you can see on this Arduino, I have pin number 7 right here, so I have inserted this. Now next sensor in your code is your CO2 sensor, which is your MQ135 sensor. So let us take your MQ series sensor, and this one again you will find with 3 important pins, and there is one more also that is unused right now, because this particular sensor comes with both analog and digital port connectivity options. Currently I am using it with your A0 pin, so I can connect it directly with the analog port. If you want to connect it with the digital port, you can use the D0 pin from here. So again we are going to follow the same set of connections. On the back side of this sensor, you will find the pin numbers or the names of the pin. So accordingly, I can see here the second pin we have is for the ground. So we can follow the connections accordingly. The ground wire I am taking and we are inserting it here. Then we have beside this the VCC wire and we can insert it here. Your last one we have is your analog port wire. So we can check it on the software side. I have connected it on A2. So the same I need to follow. And here on the Arduino we have analog port right here, and I can insert it in the A2 pin of this analog port. So now the 2 sensors are connected. Let us follow it for the third sensor. We have IR motion sensor in sequence now. So, I am taking up this IR motion sensor, and as you can see, this again has 3 different wires, your ground, VCC and data. And you can see that in the coding section I have defined I will be connecting it on pin number 3 of your digital port. So, let us follow the same. First of all, just read the names of the pins here. So, identify your VCC and ground and data line and accordingly insert the wires. So, we can see here that the middle wire is for your ground connection. So, the same I am following on the breadboard here. This orange wire is connected with the VCC line here. So, I am following the same connection on the slots here, and then the remaining one wire we have is for your data line, which is on pin number 3. So, I am following the same right here. So, on the digital port you can use it on pin number 3. We have 3 sensors ready on the circuit now. Let us pick one more, which is your soil sensor. So, as you have already used this soil sensor, it comes with a chip that we can insert into the soil and at the same time a reader module which can help you to read data from this particular conductor that we are going to insert inside the soil. And then I have inserted 3 wires here. Although this sensor again helps you to get data from the analog as well as digital line. So, you can just read the values right here and accordingly you can follow A0, D0, VCC and ground values from here and you can insert them in relevant slots over there. So, let us identify the values first. We have red wire for the VCC and this wire we have for the ground. So, let us make the connections. So, this is your common ground section. So, I am inserting the wire here. For the common VCC section, I am taking up this wire and inserting it here in the common section. And then the remaining wire that we have for the A0 line, I am inserting it in the empty A0 pin on your analog port here. So, this connects your soil sensor. Let us have the next one, which is your water level sensor now. So, this one we have already used with the water level sensing mechanism, and this sensor again comes with 3 pins and we can connect it directly with the analog port. So, on this sensor instead of writing VCC and ground, they write it plus, minus and S. So, plus will be your VCC, minus will be your ground and S will represent your signal pin. So, let us first take your minus pin, or that represents your ground pin basically, and let us insert it here on the common ground section. Similarly, the middle one I have is for the VCC. So, I am just inserting it here in the VCC section, and the last one we have is your signal pin, and as defined in your coding section, this will be connected on A1. So, we have the A1 port empty on this analog side and I have inserted this wire right here. After connecting this, we have the last sensor in sequence, which is your LDR sensor. This is basically a LDR module. On the top of this you will see the LDR sensor, and this is the remaining arrangement like your sensitivity adjustment pot you have, or the support circuit also you have on this sensor. This sensor comes with 3 pins again. We have your digital data line, VCC and ground. So, the middle wire I have here for the ground purpose. We can insert it here in the common ground. After this, we have this orange wire for the VCC, and I am utilizing it here on the common VCC section, and then we have the remaining wire for the data, and this wire will be inserting based on the coding sequence only, so which is on pin number 10 here. So, pin number 10 of course we have on the digital port, so I am using it from here. So, these are all your sensors, we have connected all of them now, but there are few actuators also that will respond based on this sensor arrangement. So, the first most actuator, let us find it in your coding sequence again. One we have is with your IR sensor. your motion sensor. So with that, what we can use is your LED pin, which is on 4 number. You can see here I have initially inserted 2 LEDs on my breadboard. So one of these I will be using with my LDR sensor, one of these with your IR motion sensor. You can see here that the cathode part of these LEDs I have already inserted in the common ground line, because the cathode we need to connect with the ground. The anode section now I need to take to the Arduino pins. So first one of these I will be using with your pin number 4 as defined in your coding sequence. So inserting the wire right here with the pin or with the vertical port connected to this anode LED, and then we have the pin number 4 here on your digital port. Similarly, we have it with another LED that is connected with your LDR on pin number 9. So I will be taking one more wire and I will be inserting it in your vertical connection of this white LED and inserting it on pin number 9 of your digital port beside this existing pin, which is pin number 10 for your LDR. So beside this only I am connecting the lamp of your LDR. Now we have connected both LEDs. The last actuator we have is your buzzer, and for buzzer again we have buzzer module here with 3 active pins, out of which of course one we are going to connect with your ground. So there is one minus pin that we will be using on the ground terminal. So I am inserting it here. Then we have the middle one with VCC. So inserting that one here with the common VCC. The remaining one is your signal pin, and let us see where we have connected it. This shows pin number 2. So let us follow it on the pin number 2 from your hardware side. So now all your sensors and actuators are connected, but as we discussed, we need a display on the hardware side. So for this we have the last component with us, which is your LCD with I2C chip. So this will create your ultimate hardware display, and as we have done it in the previous session, we have 4 pins over here, your VCC, ground, SDA and SCL pins. So let us start with the ground first. The first most pin here in sequence is your ground. So let us take it to the common ground, and then we have your common VCC that we can insert right here. After this we have the remaining 2 pins. So the first I am taking is your SDA pin, and as you know we have the SDA pin on the end, second last pin of your digital port. So this is your SDA. You can follow the pin diagram of your Arduino board for this. The most last one pin on your digital port is your SCL. So the same I have connected. So your LCD board is also connected now. For the demonstration of this, because we have a soil sensor and a water sensor, so I have brought up a pot for your soil as well as water over here that we will be using for the sensing purpose now. But before we do that, let us insert your USB into the system here so that we can start your code upload. As soon as I inserted your cable here, you can see that most of the sensors are now blinking some lights because we have connected them with the power supply. So you can see the on LEDs on all the devices. This will be the first indication that you have connected everything right. If something is not right, those sensors will not be turning on. So we can ensure everything from these lights that are turning on instantly. The next thing we have to do is this soil sensor we can insert into the soil pot here, and similarly this water level sensor we can insert into this water pot over here, and accordingly we can make the measurements one by one. So let us go back to the coding section and we will be uploading this code now. So the first thing we do here is go to tools, identify your board and then identify your port. So COM6 I have connected, and now you can compile your code because I have compiled it already, so I can upload it directly. So, uploading your code, because this is a bigger code, so it will just take a few seconds to compile, and after that it will take some time to upload as well. So, we will just wait for a while, and then your this sensor system will start working, and we can see the data on screen as well as on your LCD board. So, we can see done uploading on the screen right now. So, let us open your serial monitor, and on the serial monitor right now you can see the set of readings from all the sensors. Depending upon what were your initial values and how your sensors are placed right now, you will be getting some values right here, because your this LDR sensor as well as your this IR motion sensor are currently facing the ground here. So, they are automatically finding some obstruction. So, accordingly one LED is glowing automatically. If I take it up, for instance, upside, and if there are no obstructions in the surrounding environment, this LED will turn off automatically, because in this case I have some obstructions around. Since there is a wall, there are tables, there are some chairs around. So, that is why this sensor is still sensing and the LED will stay on. But in your case, this will turn off if there is nothing around. At the same time, with the LDR sensor, this one we can close like this, and you can see the other LED is turning on, and if I take it out, you can see in the brightness the LED is turning off. So, these are the connections with your LEDs. Then for the water level sensor, if I insert it inside, you can see some readings of water level sensor on the screen right now. We have it up to 125, but as you know, the threshold we created is 400. So, as soon as the value reached above 400, you can see the buzzer ringing over here. So, that observation we can have from the threshold. Whatever threshold and whatever delay you have added into the system, accordingly the buzzer will ring. And one more we have is with your soil sensor. So, currently your soil sensor is showing a moisture value of 926 approximately. So, this sensor basically provides you high value when there is a dry soil and low values when there will be less moisture. So, if I use slightly some water and I pour it inside this soil bowl, you will see a fall in your readings. You can see it is now 344 because I added some water into the soil. So, accordingly we can balance everything within our field environment and we can see the readings on real time basis. And there is one more interesting task that you can do. I have already explained you how to use a ESP board. We have used that with your air pollution monitoring project also. We have learned to send data online. So, on this project now, your assignment can be like you can create it with a ESP board and you can even send the data online to have this continuous monitoring. However, the basic design we have studied here and we have seen how the readings change based on your field environment. So, I hope we have learned some interesting facts from today's project and you have also learned how all the basic sensors you can combine up into a single project and we can use it for a specific application. So, I hope we have learned several useful concepts and we will be using this information for variety of new projects that you can create later on based on this initial logic. So, thank you very much participants. See you again in other videos.